Hi, Intro to Algebra. First, just a quick reminder that when we graph inequalities, these are both less than, so they're going to the smaller numbers. And this one has an open circle because 2 is not a solution. It's not true that 2 is less than 2, right? 1.997 would work, something very close to 2, but not 2. And this one is filled in because 2 is less than or equal to 2. 2 is included in the solution set here. It's worth noting also that if you write these in a different order, for example, if we write 2 is less than x, realize then that means 2 is smaller than x, so x is bigger. So if we were to graph this one, again we'd have an open circle, but we'd be going to the bigger numbers because x is on the bigger side. A lot of inequalities solve just like we solved equations. So for this one, it's going to be just like a two-step equation. We'll add 8 to both sides and then divide by 6. So anything that is bigger than or equal to 8 should make this inequality true. So you could try something like you could try 8. That should work. 6 times 8 is 48 minus 8 gives me 40. So that's exactly equal. Let me try out something that's bigger because that should work also, like 10. So 6 times 10 is 60 minus 8 gives me 52, and that's also greater than 40, so that still makes this true. When I go to graph this, I want to show anything that's bigger than or equal to 8. It's going to be a filled-in circle because it's greater than or equal to going to the bigger numbers. When inequalities get different is when we start dealing with negative signs being multiplied and divided. So for example, let's look at these two inequalities. Here we're going to divide by 3 on both sides, and we get x is less than 5. And that's great, and if I try out the numbers, anything less than 5, like 1. 3 times 1 is less than 15, that works. Or 4.5, if I do 3 times 4.5, that gives me 13.5, and that's still less than 15. But let's look over here. What happens if we divide by -3? Well, then I've got x is less than -5. So let me just try that out. Think of numbers that are less than -5. Try -6. So -3 times -6, that gives me a positive 18. And that is actually greater than 15. So that doesn't work, right? So there's something funny going on here. And in order to preserve this and make sure that it still is true, when we divide by a negative, we have to switch the inequality sign. Okay, so we switch the inequality sign from a less than to a greater than, and now this inequality will work. For instance, anything greater than -5. So let's try 0. So -3 times 0 is less than 15. That's certainly true because 0 is less than 15. So let's look at a few examples of when you switch and when you don't switch. So for this inequality, so far I've subtracted 3 from both sides, and I've got 2x is greater than or equal to -12. I have not multiplied or divided both sides by a negative number, so I have not switched the inequality sign. I'm going to divide both sides by 2 now. The thing that is doing the dividing is a positive 2, so we do not switch the inequality sign. Let's look at a similar example. So it starts off almost the same. It's just that I've got a negative sign with the 2x. So now when I divide, I am dividing by a negative on each side. And so I'm going to get x is less than or equal to positive 6. And so here I did switch. Here there are lots of negatives going on, but we're not going to switch because we're not going to multiply or divide by a negative. Here to solve, I'm going to multiply both sides by -4. And since I'm multiplying both sides by a negative number there, -4, I am going to switch the inequality sign. So that should help you get through your DeltaMath assignment. And remember, there is a watch help video within the assignment as well if you get stuck.